Good day, everybody. So this goes for our second video of chapter 4. So today we are working on 4.2, which is uniform distributions. Okay, so the word uniform meaning all the same, right? All the same. Okay, so this is when all our outcomes in a single trial are the same. Okay, so all the outcomes or all the probabilities of the outcomes are in a single trial are the same. Okay, so the formula for that is the probability equals 1 over the total. Okay, so all over the outcomes. All right, number 1, a computer randomly picks a number between 1 and 6. Okay, first question, are all the outcomes uniform? Well, if a computer is randomly choosing, then there are 6 options. Those 6 options are 1, 2, 3, 4, 5, 6. So if it's random, then each number has an equal opportunity of being chosen. So this one is yes. Yes, each number has the same chance or probability of being chosen. Okay, calculate the probability distribution. Okay, so remember in our previous lesson in 4.1, when it said probability distribution, we wanted a chart. Okay, so just to refresh you, we had one over here, and this is 4.1. So probability distribution, I said make sure you guys make a chart. Okay, so now 4.2, same thing. We want probability distribution, so we'll make a chart. Okay, so I'm just gonna put this on the side. So the chart is the outcomes, which are X, and then the probability of each of the outcomes. Okay, so probability distribution is a chart. So our outcomes, so what are the different outcomes that we could have if we're choosing a number between 1 and 6? Well, that would be 1 to 6. So 1, 2, 3, 4, 5, and 6. Okay, so now the probability of each of these being chosen, okay, so the chance of choosing a 1 would be 1 out of 6. Okay, for 2, it'd be 1 over 6. So going back to our formula, it's always 1 over the total outcomes. So 1 over 6, 1 over 6. So each of them has a 1 in 6 chance of being chosen. Okay, so that gives our probability distribution. Okay, so again, our outcomes 1, 2, 3, 4, 5, or 6, and the chance of each of those being picked or chosen is 1 out of 6. Okay, so C then says calculate the expectation and interpret its meaning. So keyword here, expectation. So I told you that expectation, let me pull my chart from 4.1. Remember, expectation or expected value is E of X. One sec, that's just my dog again. Shh. Oh boy, come here. That's Coco, by the way. Okay. So that's expectation or expected value, which is E at X, and we have our formula here with sigma. Okay, so going back. 1 second. So expectation or expected value, so we're doing the sigma, and it's each outcome times it by it probability added together, because remember sigma means the sum of, so we're adding them all together. So it goes from our initial 1 to our final. So our first outcome is, which we have here, is 1. So we have 1 times 1 over 6. So the first outcome times the probability, so 1 times 1 over 6, plus, because it's sigma, means sum of, so add our second outcome, which is 2 times its probability, which is 1 over 6, plus 3 times 1 over 6, all the way to 6 times 1 over 6. Oops. So what we get is 1 over 6 plus 2 over 6 plus 3 over 6 plus 4 over 6 plus 5 over 6 plus 6 over 6 equals, so 1, 3, 6, 10, 15, 21 over 6, which is roughly 3.5. Okay, so that's the expectation. So what now the next part? So that's our expected value. And now we're going to interpret its meaning. So this means the average value of the random number will be 3.5. So the average value of the random number will be 3.5. So if each one of them has an equal chance to be chosen, if you add up all the probabilities times the outcomes, that will equal to 3.5. Okay, question number 2. Okay, it seems a little bit confusing, but I'll explain this. A spinner has 5 equally spaced sections labeled 1 through 5. So again, we have a spinner. So let me see if I can split this into 5. Oh, that's only 4. Fail. So something like this. So 1, 2, 3, 4, and 5. Okay. In a particular game, a player wins points equal to double the section's face value if an even number is spun. Okay. So what that means is, so again, player wins double the points equal to the section's face value if it's an even number. So what that means is if they spin it and they land on a even number, so a 2 or a 4, they get that value doubled. So if they were to spin on a 2, they would get 4 points. If they were to spin on a 4, they would get 8 points. Okay, so if it's an even number, they get double the points. Okay, next, for all other spins, the player loses the face value of the spin. Is this a fair game? So let's get to the next part. So they lose the face value. So all the other spins would be odd numbers. So they would lose these as points. So if they spin it and it lands on a 3, they would lose 3 points. If it landed on a 1, you would lose 1 point. And if you landed on a 5, you would lose 5 points. So the question then says, is this a fair game? So for a game to be fair, you have to have an equal chance of losing equal chance to lose or win. Okay, so your winning probability or chance of winning should be the same chance of losing. So we want to figure out if this is fair. So will my points equal my losses? Will my wins equal my losses? Would it be fair? So whenever we're looking for a fair game, we're then once again going to do expectation. Okay, we want to see what the expected outcome is. So if it's equal, an equal chance of win points and equal chance to lose points, then our expectation should equal 0 because they would cancel out. Anything other than 0 would not be a fair game, whether it's positive or negative value. So let's go through this. But before we do that, I'm going to make a little chart again. So our outcomes, X, just like we did in the previous one. So we want our outcomes and our probability. Okay, so our outcomes are not these numbers yet. So we are able to win a 1 or spin onto a 1, 2, 3, 4, or 5. Okay, but our outcomes are actually the points. So if we spin on a 1, we lose 1 point. So if we land on here, our outcome is -1. We lose a point. If we spin and we land on a 2, we get double the points. So our outcome is a 4. Positive 4 because we're gaining 4 points. Then if we spin a 3, we lose that because it's an odd number. So we lose 3 points. If we land on a 4, we get double. So we get 8 points. And if we land on a 5, we lose those points. So we lose or subtract 5. Okay, so their outcomes are the points in this case. And the probability of each one is 1/5 because an evenly spaced spinner. Okay, and they have to be the same if it's going to be uniform distribution. Okay, so now we're doing expected value. So now it's again the outcomes times the probabilities added together. So -1 times 1/5 plus 4 times 1/5 plus -3 times 1/5 plus 8 times 1/5 plus -5 times 1/5. So we get -1/5 plus 4/5 plus minus 3/5 plus 8/5 minus 5/5, which gives us -1, +3, 0, 8 minus 5 is 3. So 3/5 or 0.6 points per spin. So if you were to play this game, on each spin, you're averaging a positive 0.6 points. Okay, so if you play this long enough, you're going to keep gaining points. Okay, so since this is not equal to 0, this game is not fair. Not fair. The expectation is not equal to 0. Okay, and that concludes the lesson for today. So again, uniform distribution. We're going to go through 3 different distributions: uniform, binomial, and hypergeometric. So uniform, the probabilities are the same in a single trial. So you got to make sure we're doing a single trial. Okay, so here we did the numbers between 1 through 6. So each number has an equal opportunity to be picked or chosen. Okay, and likely if we're doing a spinner, if we spin it 1 time, each of them has a 1 in 5 chance to be chosen. But here the points are your outcomes. Okay, homework, page 157, 1 through 5, 7, 8, 11, and 13. Okay, so 1 to 5, 7, 8, 11, and 13. Okay, so it concludes the 4.2 or the second lesson for this chapter. It does get a little bit more difficult, so please stay up to date and caught up with the lessons. As you guys know, that school has now been pushed to May 4th as per the government yesterday. So please try your best to stay up to date with the information for you, especially for those who might have to take statistics next year in university. If you don't go through the next couple chapters with me as I'm going, it's going to be extremely difficult for you next year. So please stay up to date with the content I'm delivering. Okay, I hope you guys are all well. Any questions? Haha, Teja, Kenneth.